All right. Good afternoon from Ghana. Okay. Yeah. Good afternoon. Uh, Alice from Ghana. Uh, good time zones to you all. I don't know if we have a foreigner joining. Okay. So what's up? What's up? This is the second session. We definitely have to finish routing the PCB. So I won't waste any much time. Yeah. So any questions from the previous section? Any questions from the previous section? Yes, any section from any questions from the previous section? Can you guys hear me?
Yes, please.
Okay, so any questions? Any questions? Okay, if no questions, then I think we can start. All right, so I'm going to switch my keycard view and then stop presenting. Hmm. Okay. All right. So this is where we left off. Let me share. This is where we left off. We only routed we only routed what we call the differential pair signal. Okay, so we're going to continue with the rest. All right. So usually, like I told you in the afternoon, I always route sensitive signals first. Okay. So what I'm going to do is to finish up these guys here now. Uh, Yep, I can just do this. You can see that there is we poured ground on the board. Okay, the board itself is tied to ground. However, you can see that because of the clearance, this ground is actually broken. Is that okay? That's why this ground net is connecting. So what we can do is we can actually push it via a via and tag it over there. Do the same for this one. I'm gonna turn off. So okay, this is given because of this 5 volts here. So let me do a little adjustment now. Sometimes because you see the clearance we set on 5 volts is so wide, okay, that's why it's not allowing us to route through here. So sometimes all you have to do is to go back and adjust it, okay, because if you don't, you can actually route it. So let's go back. That IC, I think the clearance of 2 is okay. So we will set it back, but that will be after we are done routing this particular IC. Okay, so we need a ground. All right. So I'm gonna push it here. Okay, so what I have placed there is called a via. Okay, it's a metal that is running from the top layer to the bottom layer. Okay, it's connecting the top layer to the bottom layer. I can actually show you how it looks like. Yeah, I should be able to see. Come on, I should be able to see it in the 3D model. Sorry, the 3D viewer. Okay, you see that there is a piece of metal moving from the top to the bottom. Okay, so let's see. All right, I don't know. Good. So KiCad actually allows you to view inside your board. Okay, so you see these metals, this particular one, the smaller one here, this is the via we just pushed. Okay, that's the via. Now some of these are so you see the via connects the top part of your board to the bottom. That's what it does. Now and these other ones are all pin connections. Okay, so that's what the via is used for. anytime. So that's the whole you are seeing here. Okay, that's the whole of the via that I just created. Okay, it's under this IC. Because it runs from top to down, that is why you are seeing these holes over here. Okay. All right. So if you want to see what is going inside there, you can zoom in. I think this really gives a very nice view of what is happening inside of it. Okay. All right. Okay. So that's a via for you. Let me double check and be sure my recordings are intact. Okay, all right, I have voice. All right, okay. So, as usual, we are routing sensitive signals first. There is another one here, and just push over here. Okay, all right. Yeah, and this guys, we can. In fact, I think I'm going to change and move the D plus rather onto pin 6 and D minus onto pin 5. Okay, so that at least avoid I can avoid. Oh, let me see if I route. I can actually avoid it. So I can tap this here. Let me probably tap it on the pin just when it has been intercepted, so that uh, okay, and just like that I'm able to. But yes, I think this is the best. This is the best. There is no need changing again. All right. So because of where I've routed it, I don't even have to worry about this because the signal is coming from here and I'm tapping it on the parts themselves. So this actually doesn't add up to the transmission, but it will be able to deal with any transient. Okay. All right. So let's also see if we can route this 5 volt. Okay, so this 5 volt, we set the net on about 5. Okay, but I can press on Q to set a different value for it. So let's try a point 3. Yeah, so we can actually route it on a point 3. All right, so let's route all these 5 volts so that we can now go ahead and set our 5 volts back. There is another ground here. Okay. Okay. So I think we are good. We are good. We are good. We are good. This net we route them later, and not very late, but I think okay. All right. All right. All right. All right. All right. All right. I think I'm gonna move this from here to this place instead. At least it will nicely align with my with the fuse. Okay, and then I would move this here. All right, so that we have enough room here to route our V bus. Okay, so I can route. Now, the main thing I'm going to try to do here is to put all my signals on the top layer. Okay, if I'm able to do that, that means technically I would have microstripped all my signals, which is a good thing. Is that okay? I would have microstripped all my signals. So that's what I'm going to do. Everything I'm going to route, I'm going to make all my traces stay on the top part as much as possible. Okay? Even if I'll touch the bottom, it's going to be just a few traces on the bottom layer. Okay, so for V bus is a power, it carries power. Now, the moment it changes to blue, it means that the net is going to the bottom. Is that okay? But we don't need this to be on the bottom. So I'll press V to bring it back to the top. We already set the size and dimensions of the V bus. But I think we still have enough space to actually make this bigger. So let me set this to 0.5, 1.5. Yeah, because the power will be traveling quite a distance from here. So at least if we make it, we make the width thicker, it reduces the inductance and we can have a lot of current going through. Okay, what else? You route the 5 volts later, and okay. So the next signals I'm going to route would be, let's go back to point 3, would be this guys here. Okay, what net did I set for them? Please feel free to chip in your comments and questions when you have to. Okay, so let me put this back to point 3, and I'm going to try and use a minimum of 4 over here. I will adjust it in a situation where I cannot, in a situation where it is too huge, I will adjust it. Oh, okay. So let's set a 3 on this. That's why that VR was very, very big. Let's maintain a VR of zero point 0.6, the VR hold. So let me go back here. I think I want to delete these guys. I can actually select them and edit that property. Yeah, because you can see that's why the hole was very big. I need it to be. So I don't want so many holes coming out of the board. Okay, so the next thing I'm going to route will be this. So you see, the whole thing was done during the arrangement. Okay, I really arranged the components so that they will be easy to route. You can see that right now all we are doing is snapping things in place. Okay, this guy here can just put him. This will not be good when you are putting a trace on a pad like this. Okay, make sure your trace size doesn't extend beyond your pad. It makes it difficult to solder when you are doing a reflow. The component finds it difficult sitting because the area around it that's supposed to be pulled. Okay, um, I wish I could talk about this, but it's okay. But for now, just take note when you are connecting something like this. You see, the thickness is more than the pad. Always avoid such a thing. Okay, probably in any future we can talk about it. Right, let me talk about it right now. You see, when we are assembling these things, we use a technique called reflow. Okay, so what you do is you put soda paste on top of these parts and then put them in an oven with the component on top. So when the soda paste is melting, what happens is that it pulls the component in place. Okay, by the force of surface tension. Using the surface tension, the component is the paste is able to when it melts, it's able to pull the component in place and even make it align so very well, right? But if you do something like this, then it won't get a well-defined metal area. The heat will be too spread. I don't know how to put it, but you see, this one, for instance, clearly defines the outline where the component should be placed. But this one, it becomes difficult. So you would get it shifted. Is that okay? In this case, it's going to be shifted. So this is something you should always avoid. All right, so I'm going to reduce it to zero point 0.4, and this is good. So now if we are doing a reflow, it would have a defined place to sit. Okay, and I'm going to right under this. Now, technically, this thing you shouldn't have, you shouldn't pour copper under it as we have it right now. You don't do that. So the way I'm going to prevent copper from filling underneath is this. There is this tool called keep out. Okay, so I'm going to draw a keep out zone under this. So I want the keep out zone only on the top copper. So I'll draw the keep out zone. Probably there's too much. Let me just draw it over here. Okay, so I want to make sure that copper core doesn't actually extend under this component. Okay, so I'll draw my keep out zone like that around this. I think I messed it up. Let me take it again. I messed it up. All right, so from here to there, I don't want copper in this area. Yep, we draw it. Oh, okay. Anyway, so I can do this and then do editing. So to edit this, I can push in a corner, push in another corner, and then I can extend this over here and bring this down here and move this here. Okay, it also gets the job done. Okay, then I have to set the rules for this keep out zone. So definitely I'll be routing tracks through, but keep out VS, keep out parts, keep out copper fill, and yes, so that will be the rules for this keep out zone. That'll be the rule for the keep out zone. So now let us route them. Okay, so I'll bring this here. I just want things to look symmetrical. Okay. Mm. Okay. So we are done. We are done with this side. What other sensitive nets do we have? Hmm. Okay, so now let's route power. Everything power. Okay, let's route everything power. So our main power comes here. So I'm going to set the main power on 1.8. In fact, yeah, 1.5 is okay. For the VCC, 1.5 is okay. So I'm gonna tap it. Yeah, this direction will be okay. Okay, sometimes. Now take note. Sometimes you hear people say that 90-degree bends add like 90 degrees, turning this thing 90 degrees adds some impedance. Please, that thing is not true. Is that okay? Always feel free to do whatever angle you want. The only thing is that the 90-degree corners, the right angled corners, usually when they are etching, I think that's when they have issues. They get sometimes some of the etchants can get locked there and do some stuff. Okay, but it has nothing to do with the electrical behavior, or it has no electrical effect on your route. Okay, so if you hear of anything like that, please ignore it. All right, again, remember I said don't set your track weight to be more than your path. Okay, actually, it would be a good idea to put this here instead, not here, as this is already a capacitor. We needed to filter out what is going on. Okay, so yeah, we also have to bring our 12 volts in here. Hmm. We have to bring our 12 our VCC in here. Okay, I will route this later. Definitely, I may have to do it on the back. So we route the most important signals later. So let's continue from here. I'm going to change back to my 1.5 and route here. everything I'm doing, I'm always trying as much as possible to avoid cross. Okay, so you see that I've been able to avoid that so far. So the idea is to route everything on the top part. Now look at this. Again, the wire, the trace thickness is bigger than the part. Don't do it. Okay, don't do it. So I'm going to change this to a 1, and I'll do that. Okay, all right. So yeah, now let's actually route this guy. This is the shield. Let's put it on a 4. This is the shield. So we connect our shield. Then we have a V bus here. The V bus is actually supposed to have the V bus is supposed to have. Let me move it much away from my differential signals so that I can have ground around my differential signal, so they will act like a coplanar differential. Okay, so let me even allow here. Let me allow more space around it. All right. So now, if I feel, you see, I have what do you call it? I have ground around my signals. Okay, that's what I intend to do. Okay, that's why I allow that space. Okay, we're still routing. Now this guy here, it's definitely okay. So it's actually not a problem. You see, this fuse is actually bringing, it's a main carrier of current, so you take note of that. Let's put it back on a 1. Let's put it back on a 1, and we can route this through here. This guy just need a little bit of the current of the current, so we'll put him on a 0.4 and route it through here. Okay, so you see that once again we have been able to avoid a potential cross. Okay, that is the idea. I'm trying so much to route everything on the top plane. Even if I'll touch the bottom plane, it should be a few number of traces. Okay, now this would have to cross. However, I have two important signals that I'll have to move from here. What signals are they? So when I route those signals, I'll probably handle that. And now we can easily, uh, okay, why is it not allowing? Okay, so this one too, we can tap from here, from the main line. Let me make it a bit nicer and that, okay. But you realize we will actually need more 5 volts here. Okay, so probably we can still tap it from this line. Then so what I'm going to do is I'm going to increase the width of this to the normal size, which is 1. Okay, and then let me delete this for the meantime. Okay, then come delete. So I'll should oh okay, there is a tiny one there. Okay, so I want to repeat this. I want to repeat this over to this place. Okay, so that now I can easily connect it. It's 5 volts, so let me tap it on the main net. Okay, something like that. And you see, we have still managed to avoid this crossing. Okay, so now I can link this straight up, okay. And now let's also route this 3 volts line. We will need some space here, so let's adjust this guy so that we have space to. Now this 3V3, this guy is actually not even supposed to source so much current, right? So I'm going to put him on a 0.5. because it is still a power line anyway. I think it didn't pick the 0.5. I'll correct that, and I can actually let's clean it up, and there is we will need a place. Actually, let's probably route the reset signal first. Okay, this thing would definitely need me to cross. Can I avoid it? To definitely require a cross. I don't think I can avoid this. I don't think I can avoid it. So this reset, okay, we'll deal with it later. So I'm going to leave it over there, and then I'll definitely have to cross. Definitely. Okay, you definitely have to cross. Okay, so if I set a 0.5 on my net, can I route my okay, so unfortunately we don't have any choice. Okay, we don't have any choice. So uh, so when you push a via, it's supposed to go over the next layer. Okay, so this is the first breach we've had in our back. But then, remember I told you that if signals, you have to route across like that, then make it orthogonal, right? So you can see this is going like that, that's going like this. So there is no way we are going to have interference. Besides, these are not nets that have that are oscillating. So that's okay. That's okay. This 5 volts line. Oh, actually, hmm, my plan is to pass my VCC through here. Okay, that's the plan. Let's see if that is a good one. Let's see. I think for now, yes, we can say it's a good one. For now, we can say it's a good one. But this guy is seriously going to cause problem. But while it is technically not much of a problem, we can still manage it on the bottom. We can route it on the bottom, okay? Because we wouldn't be interfering with the ground plane for the signals here are not transmission lines, okay? And even if there is a necessity for that, we are just crossing over a very short distance, which is okay. So we have dealt with this. I've dealt with this. Okay, let's deal with this. I'm gonna put it on point four, and then we tap from here over there. Okay, a ref. Let's put you. Let's connect you. Right. Sometimes when you finish, you can rearrange stuff and optimize some of your traces. Okay. For now, let's just route. Okay. All right, now let me quickly route my analog lines. Remember, they are analog signals, so it will be a good idea to have them as coplanar microstrip lines. Okay, coplanar means have ground surrounding them, and microstrip means having a ground plane beneath them. Okay, so that's how I'm going to route them. So I'm going to ensure a lot of space in between, and then yeah, I think this works. So much space in between. So in that case, interference would be reduced. Okay, straighten it. So for those of you just entered, I said that sometimes you hear people talking about the fact that, oh, don't do 90-degree bends, it's whatever, whatever. Please, none of those things are true. Okay. When What I would say is, don't do them because of manufacturability. Okay. According to some manufacturer article that I read, when you have 90 degrees corners, usually when they are doing the etching, some chemicals can actually enter there and distort that sharpness that you think you have. Okay. So that's the only thing. But in terms of maybe changing your impedance or something, please, none of those things are true, or is true. Sorry. Okay, so let's route this guys beautifully. This okay. Anyway, it's cool. All right. So yeah, we are done with almost everything on this side. RST needs to move. RST. We don't want any problems. Okay. All right. Let's probably deal with this guys too. Let's deal with this. I think I'm gonna move this and put it here instead. Oh, okay, okay. I said it's a capacitor for the RST pin during when you are doing programming. It's supposed to work with the DTR pin to auto reset. You are doing okay. So let's keep it on the reset. All right. So zoom in and connect. I like it. Yeah, probably something like this. Okay. And we can also easily connect over here. Okay, I think it is much easier routing the SMD version than this two hole. Because the last time I did an SMD version routing, I was able to avoid a lot of uh, I was able to avoid moving to the bottom copper. So at here I think we may interfere with the bottom copper. uh, Okay, so we keep it on 4. Okay, so RX, and again, digital signals, I would want to keep them as coplanar microstrips. Okay, so I'm going to allow ground between them. Okay, so if I feel right now, you see, you see there is enough space here to allow ground to flow. Okay, so right now if I should push a ground there here, I can feel it. Okay, so you can see that I have a ground in between. So that kind of isolate the two signals. Okay, so we will check that later when we are done. So for now, let's maintain the routing. Hmm, this thing. Okay, okay. All right, move this. I thought somebody just entered. Okay, let me turn off this. Okay, we good. Now, this guy is here, always causing problem. So over here, we may not have the luxury, but we will still find a way to make them have proper separation. Okay, okay, and we're going to clean this up a bit. Okay, good. Uh, is this thing too close? Well, let's keep it for now. All right, so from the look at things, I have to move these guys a bit forward because I need. Wow, I will really this routing the GIP is actually not interesting. So not interesting. Okay, so let me do this. Let me move these guys from the way. I'll bring them back. So let me probably group them. Okay, I can get enough room for. So unfortunately, okay, this is what I'm gonna do. I still want ground in between them. Okay, so I'm going to push. I'm going to manually route ground between them. I'm going to manually do that. Okay, so I'll tag this here and then manually route ground like that. Just don't want the pins interfering with each other. Okay, so what I'm routing is actually a ground because okay, so let's probably keep it here. Okay, I think it is entered in so much into this space. All right. Okay. All right. So this ensures that yes, I maintain. So instead of now leaving all this huge space, I can now tag this alongside because I know it's a ground. Okay. And so far as it is connected to the ground signal, that really helps. Okay. Better. Okay. So though they look closer, they are still separated. They are still coplanar because this is actually a ground. Okay, that's actually a ground. So let's push in another. I'm going to push in another one here, and then I'll route the ground like that. Okay, so everything I'm applying is because of the principles we talked about in the first session. Okay, so I want my digital signals to be coplanar microstrip lines. Okay, so that means each signal would have to be surrounded by ground. Okay, that's what that means. So I'll push this here. Now when I update it, you see, so I've sandwiched this signal is between two grounds, so it becomes a coplanar trace. And then I can now route this since I don't have much space available. I can now route this along and not worry so much, right? So look at that, and we have. So let's clean up this site. Let's clean it up. Yeah, well, maybe later I can actually do so much cleaning. Uh, I think my default spacing, let's see, what is it? You set it to 3 in case it is not okay. Default, okay, it's 3. So okay, if 3, then it's okay. All right, so let's clean this up. There are too much bins. So let's clean it up. Okay. All right. Yeah. Better. Clean it. And then fantastic. Okay. All these signals are microstripped. Okay. All of them microstripped. Okay. We still good. So we actually have some clearance here. We have to route stuff here. Wow. This is the point where we may have to uh, break bounds. But still, let's see how beautifully we can route that. Let's continue with this. I'm going to pitch in. I'm going to push a ground here, a ground via here. Then I will route a ground because I want that trace to come get closer. Because I don't have much space to put so much space between them. Okay, so I can pin this guy here. Okay, update. Good. So remember, this is a ground, right? So now I can bring this guy and route him along and not worry about not having a lot of space in between, like that. Okay, let me probably fix this. Okay, all right. Co-planar, co-planar. Okay, we'll probably later come back and do some cleanup in case we have more space. Okay, so you can see that I have kept I've designed a keep out uh, under this to make sure that there is no copper pole under it. Okay, it has to see the dielectric. It has to see. Okay, so I'm going to push another ground through here and then route a ground. I'm routing the ground so that I can keep my signals closer and also be sure that the ground will actually be there because like I said, I'm treating all the lines as coplanar waveguides. And since over here I don't have much what do you call it? I don't have much space to put uh, between them like I did over here. This is a good way to achieve that. So once I have routed the ground, now I can route this to make it join so that it forms something like a bus close to each other, but actually separated by ground. And yeah, okay, that's great. Please, if you have any questions, you can ask. Okay, if you have any questions, feel free. If you have any questions, feel free. Yeah, we still have a few more to route. Definitely, we will be crossing, but let's try our possible best not to cross too much. Okay, that's the idea. We don't want to cross too much. Don't want to cross too much. Actually, I think here I'll even realign them. Just for, I mean, I can leave it like this, but I'm not. Okay, okay. I won't do anything. I'll just leave them like that. So here, what I can do is to push. So I can push this over there, over there, over there, and connect that broken area to ground. Okay. Now I can select this go to special tools and do create array. Okay, now I want on my horizontal just one, but on my vertical I want four. I need them separated by 1.27, 1.27. Okay, if I hit that, say a tag sum. So let's probably add more. I mean, we have that all that space, so we could probably put seven of them, or let me make it six so I can just copy and paste them here. Okay, so I'll say delete this and that, and in fact this is actually not very necessary because we are not doing any current heavy stuff over here. Okay, but I mean, uh, sometimes you just have to do things for the fun of it. Okay, and I'm going to do the same thing here and the same thing there so that they all be properly connected to ground. And like I said, you don't need all this. So maybe I'm gonna take away two each so that to just be left with four. Whoa, I thought I was selecting. Right. Please, if you have any questions, you can feel free to ask. Okay, so now if I hit B, see that it fills in the ground automatically, right? Now they are co-planar and also nicely spaced. Is that okay? So there is no way we're going to have interference. Besides, beneath them is a solid plane. Okay, if you check the bottom, it's never disturbed. That makes these signals microstripped. Is that okay? And the fact that we have ground, they are all surrounded by ground, makes them a co-planar, co-planar, co-planar waveguides. Okay, all right. Yes. We will do the same thing here. Probably here two will do. So I'll copy two of this and where should I keep them? Yeah, I'll be putting labels here, so this place should be okay. So two, and two, and another two. Okay, and if I hit on a B, fantastic. So you can see, first of all, they are micro stripped, and also they are co-planar with that. Okay, because of this ground, which makes them happy. All right, we still have some stubborn routes to handle. There is always a stubborn route. Now over here, I think we've broken the ground. So this is usually a good place to put VS. Okay, so I'm gonna put one, two, and a three. Then probably put one here and another here, just to give the ground a strong tie to the bottom. One here and one there. That will do. Okay, so in fact, let's focus on the routing. We'll do this ground stitching. What I just did, we call it ground stitching. We'll do it later. Let's just ensure. Okay, so we have, wow, four. We have four more to deal with. Four more to deal with. Who is calling me at this time? Okay, thank you. We still have four. Hmm. I really don't like this idea. Okay. Anyways. Which can we sacrifice? We definitely have to go beneath. Definitely have to do that under. Okay, so let's probably get rid of this for in the meantime. And yeah, let's get rid of the 3V. I mean, it's not necessary for our board. We can worry about it later. The reset tool we can manage. It's not a signal that you'll be using often anyways. So let's route the important ones first. At least we could still move a couple of signals through this place. Okay, we still move a couple of signals. So I'm going to okay. So I'm going to do another ground plane routing here. I'm going to route another ground, and then so that the next thing can be microstrip. Okay. If I had enough space to space them out, I wouldn't have done this, but because I'm keeping them so close to each other, that's why I am doing this. Okay, so just understand the reason. Okay, I'll push this here, and then now I can route D10, can also join the queue. Wow, the space is already gone, but at least we've done well. We've done well. We have done well. So after this, you'll be left with okay, okay. But now we can't route this on the surface anymore because we are almost out. But let's see. Look, we still have some space over here. If I drop this down like that, I think we should be able to get some space back. Oh, if we drop all this, that's going to be too sharp now. Okay, I think at this point we don't have any other option than to break the ground. Yes, yes. Let's see. We can manage one more through here. So probably let's manage this. But if I okay, let's manage it. But if I do that, I won't actually get anyway. I'm still going to take it anyways. I'm going to route my ground. And yep, the problem begins. Problem begins, but wait. Um, if we move this IC a little bit backwards, right? Sorry, if we move this capacitor, yes, capacitors are not supposed to be too far, yes, but we just want to manage it a little, right? So this is just a little compromise. Whoa, slow your horses, please. Okay, so this will be point 0.4. Can you take point 0.4? No. Oh, actually, if we do that, we can still route this from here. So let's see. Let's move this on point three. The ground. So let's go back to who is this? Okay, so it's a 5 volts. Wow, 5 volt is on a point two. So why is it not allowing? Oh, okay. So let's try dot two. Yeah, I think that's what we used. Something like that. Okay, but even still, we would be wasting it. We would be wasting it. We would be wasting it. Don't worry. Let's still go. Let's still go. Think. Okay, we will come back to correct it. Continue routes. So even if we have to cut through our plane, we're going to do it so romantically, okay? So that the board is still J. Okay. Next. All right. So let me correct this bumps on this guy. You can, if you want to delete, you can just click on it and delete it. Okay. Yep. And then now close them up. All right. Now let's try and move on the point four. Let's try and move this guy. Yeah. Okay. Well, at least we managed one more, brother. Okay. But there is a problem. We solve it. We solve it. No worries. Let us solve that problem. That's why we are engineers anyway. Okay. So on the B, good, good. So you can see that this place is actually used up. So technically, any other signal that will come, I'll have to get another space to, which would definitely be on the bottom. Hmm. And I'm going to do that creatively. So just watch, okay? Let's clean this up. Let's clean this up. It's supposed to snap. Okay. Can press U to select the entire length. Delete. Okay. All right. So I'm just cleaning it up. We have to finish this in this session, but the last session is the last for this training. Okay. I think it looks good. Yep. Should I or should not? Yep, you should. Hey, you people have become too quiet on me. Oh. What's happening? Are you guys doing a coup d'etat? You want to overthrow me? Please stop, okay?
Oh, we are watching. We are watching.
Uh, because right now, when people become silent, it's dangerous. Okay, so you see the stress I'm going through, and you see a beautiful board. And I mean, this is Arduino, just a few lines, right? But it's still stressful. Uh, I can probably move this guy closer away from there. oscillator. See, when you are doing these things, no space is small. If I can get, uh, okay, you know what? I'm going to push the ground via here and round it to surround this guy so that I know that I have isolation between them. Okay, so even if this crystal should make noise, this ground would be there to handle it. Okay. All right. All right. All right. All right. Okay. So now you see we have three more digital IO pins. Actually, two. Oh, that's even better. We have two, and we don't have space to route it on the top side, so we have to route it on the bottom side. Okay. Now, if I do that, I'm definitely going to disturb my, what do you call it? I'm going to disturb my microstrip something, okay? But fortunately, you see, I routed some grounds, okay, along, okay? So I can actually use those grounds to kill, to kill two birds. Okay, the same ground. It is going to serve as a coplanar for this surface traces. But then, if I tag this signal under it, then in a way, it could be like a microstrip for that signal. Okay, so look at what I mean. So instead of routing on top, I'll move to the bottom. Yes, and I'm going to disturb this a little bit. Probably let me do this and go straight so that I have an orthogonal. Then I'm going to try my best to target just right under this ground line. Okay, so this ground line is going to serve as a coplanar guide for the top routes, but then it will also serve as a micro strip. It will serve as a return path for this guy. Okay. Got here. All right. So once I get here, I have to exit it. Okay. Should I can actually exit through here or continue to tag along? Okay, we still have some signals to deal with. So I will branch here. And again, I'm crossing, so that is not much of a problem. And then maybe just right here, I can come back to my top plane and connect that. Okay. So yes, I have disturbed it, but creatively. Okay. I've disturbed it, but creatively. Okay. Uh, but I think I made a mistake. I should have actually routed it on this particular one. Okay, so this is what I'm going to do. I will break this connection up to this point and also break this connection. Oh, there will definitely be an overlay. Okay, let's undo. Let's undo. Okay, because I have two more. In fact, I have this ARF is not something I'll probably worry about. Okay, so this is what I'm going to do. I'm going to let route this under this ground, then route the pin13 under that ground. Okay, so come out, cross it orthogonally, and then jump onto the track, target along it, so that it's also served as uh, okay. I thought I missed it. I think I did. Okay, so route it under the ground. Okay, and right at this point, I can again get out orthogonally. Right at that point, I would exit. I would exit. I would exit. But I still think there is a problem because now, if I want to tag this along, when I get it, it will be very difficult for me to exit through. So let's move this. We have to do a crossing, definitely. So let's exit at this point rather. Yes, we will clean things up. Then I'll bring this guy to again. Uh, Probably. Let me just tag another plane waveguide on this and do the same thing I did for the top. Okay, so I'm gonna move this. I'll come back to clean it. Okay, so move this, move that. Okay, so my waveguide and then push him here. Okay, push him here. All right, yes, done. So please go ahead.
Yeah, please. I wanted to ask, would it be possible to let the pin 13 rather follow the ground all the way to close to the end before it joins?
So yeah, I'm yet to route the pin 13. I haven't routed it yet. I don't know if that's what you are talking about, but this pin 13, I'm now about to route it. Okay. And again, I'm going to let it tag along this ground coplanar that I did on the top. So even though I'm breaking, I still have it sorted. I don't know if that's the question you are asking. If not, then please come again. Okay, so the pin 13 is tagging along right now.
Yeah. Um.
Uh-huh.
Please, what I wanted to say was, instead of letting the pin 13 come out at this point,
Mm-hmm.
why wouldn't it go follow the ground to where the ground ends and come out from that side?
I'm still not getting you. As in follow come out here. Oh,
No, the ground that the pin 13 was traced
following.
to go.
Yes, as in come here, right?
No, from like the other end, where where this pin connects to on the
He-
IC.
Here.
Instead, yeah, instead of it coming out from this point,
As
why
in
wouldn't it
as
like
in instead of bringing it to the top surface, right? That's what you mean.
no, like instead of bringing it to the bottom of the IC, why don't we rather send it down to the the side between the analog and the IC,
The side between the analog and IC.
where down uh, I don't have the means of
You mean here?
no, like how do I say it?
I'm seriously not getting you, but
The place where the ground that it's just
this
followed
ground. You mean this ground or the top one?
the pin 13, the
This
top
is pin
ground that
13.
yes, the ground that was lined on top that it's
This
traced.
one. You mean
Yes,
this
please.
particular ground, right?
Yes, please.
Uh-huh. You are saying
Yeah, this ground where this ground ends beside the IC.
where it ends beside the IC, which will be here,
The other
right?
ends.
Or here.
Yes, please.
Uh-huh. And you are
Yeah,
saying
I wanted to ask if we
Ah,
could rather
okay.
let
So
the
we should
printed
rather let it tag along to this point and branch, right?
yes, please.
Okay, okay. I think it's also doable, but I have plans of routing. See, we still have some resets and 5 volts
Oh,
to route here, right? So
okay,
that's why I left that space so that we can actually tag these guys to along some grounds and move them.
okay,
All right, thank you. Okay, so over here, one of these signals can go pin 13. I want to eject it from the bottom plane as fast as possible. I mean, I could have just tagged it back here, but that will still be too much distortion for my bottom plane. I don't want that. That's why I'm ejecting at this point. Okay, so take note of that. Yes, definitely. One of these would have to cross, and this means that we will have to do more. Ah, actually, actually, see this. I can do that, and rather come here so that my change would rather happen here. So in that case, then let me move this guy a little bit forward and that to forward and this one to forward. Okay, and then bring it up, correct it, correct this one too. All right, so now I can change, bring this guy straight up, and now tag, and I still want it as a coplanar. So try. If I want to do this coplanar, then uh, there's something I have to do first. Let me route this first. I want all the signal from beginning to end to have a coplanar. So let me route this through here first. I think definitely this place I can't do that. Can't do that. I can't do that. But let's see. Let's see. Okay. If I do this, then actually, well, probably let's just bring this guy straight up. We not move him through the top so they will not interfere. I think this is okay. I think this is okay. But I really hate the fact that I'm blocking my bottom ground. All right, so let's this guy, okay, there is a ground here. So let's tag along. Uh-huh. Okay. Then if there is a ground here, then let me just quickly cut through this at this point. Mm, just a little. Just a little. A little just a little cutting through. But please take note, sometimes just a little can be dangerous. All right. So yeah, we are done with all our signals. Oh, yeah, we have to bring some guys here. We need three. Wow, this thing again is still going to cut through, still going to cut through, and I can't also route it through here. 5 volts, well, that's not a problem because I have 5 volts here, but I need to connect these guys. Oh, I really miss the surface mount guys. Those ones are so are much simpler. Okay, so this where can I route you through? Mm, okay, so actually this particular ICSP we will need it when we are using the boot loading, right? So technically, it's not something we'll be using often, not something we'll be using often. But I can see a problem here. If we allow the if you allow this guy to go all the way through, then we have we will have a challenge taking these guys along. So what I'm going to do is still eject it at this point, and let it come up through the top. Okay, so I'll let it come out so that the bottom will be available to route the ICSP signal. So move this here. Yeah, unfortunately, this place I couldn't do coplanar. That's going to change the impedance a bit, but ah, okay. So now the bottom is free. That means that we can route these signals there because we need to send all these three signals to the bottom. So to the ICSP, I'll tag them here. Let's say that okay, we are connecting this to that. We will definitely do a cleanup, okay, and then we move this one to, can we do ICs? Can we do coplanar here? I doubt. Okay, let me see if by the end, yeah, I think we can do some coplanar stuff here. So let me try. Let me give it a try. I'm gonna push this guy here and try and see if I can do some coplanar this thing. Okay, bring it out here. Keep it here in the meantime. Oh, everything under the IC is gone. Okay, and then move this guy along. Bring them here. As they are out, we'll talk about them, their matter later. Okay, I think I can still do another coplanar over here and tag this along. Okay, uh, fantastic. And finally, move this one to over there. Okay, okay. So now that they are out, we can talk about their issues. As we will definitely have to distort these things here, but fortunately, none of our digital signals are here. And this RST is not something we'll be using often. Okay, it's a one-time thing. And even at the point where we are using it, the board is not working anyway. So if we distort this ground here, that would be okay, right? So for now, I'm going to break this and then route these ones that come here first. I'm going to break. So let's try and bring the 13. Think I can actually reduce this size. Instead of 4, make it 3, and then move them, conserving space. Okay, let's shorten this, guys. G to drag, G to drag, G to drag. So when it highlights green, it means that you are violating some spacing, okay, some spacing constraints. So take note of that. Okay, I want to delete this. How many minutes do we have to the end of this session? Okay, and I'm going to bring this guy to here. Uh, this guy, I don't have to worry so much about coplanar stuff. Uh, Okay, so let's first route this. Oops, so I've changed impedance. You remember when you reduce the impedance, so I can select all the nets. You see that it says mixed values. I want to set all of them to 0.3. The same thing. All right, let's route this one. So this guy goes here, but which signal is this? Oh, it's a ground. Ah, then we can terminate it here. Can terminate it here. And I think this is also a ground. We can terminate it here. Okay, that's nice. But this guy is gonna be problematic. But still, no problems. So let me move this to here. And again, so you press U to select the entire net, right? E to edit the net, and you can set the value that you want. Okay, so now let me clean up. Yep. Okay, so one last, that's number 11. Can move him. Actually, oh, I can't cross the resets. Okay. So what we can do is push a via through here and then cross over. Okay. And again, you can see that it's orthogonal. Is that okay? So that's not gonna pose any much problem. Oh, we actually have a problem here. This signal, where is it going to? Okay, that's the DTR. Wow, DTR is an important signal. It's an important signal. Okay, so let's rearrange the signals in here so that we can make way for the DTR under the IC. Okay, so I'm gonna do this. Okay, and then I'll shift this coplanar guy here and reroute it. So I'll bring it closer. Stops here. Don't forget to delete it. Okay, in fact, let me keep it, the width. Okay, so I'm trying to, get some space to route this particular signal. That's why I'm moving them backwards. So you, let me just tag you along. A little disturbance is okay for your life. Okay, but I think we will still have issue out here. All right, then let me bring this here so that we can easily route this through here. Okay. So you see, routing is strategy and science. Okay. You have your science, but you need strategy. Okay. So yeah, I think we're good. Now let us also move this guy. The moment you see the green highlight, it means that you are violating some clearance. So you do well to prevent that. Okay. So route over. And let me bring this closer, yeah, so that I can delete this. I think now we have enough space to route the DTR signal. If we don't connect the DTR signal properly, we will not be able to upload code, because when you are uploading code, your microcontroller has to reset automatically. It's the DTR signal that helps it to do that. Okay, so it's a very, very important signal. Okay, I think we can bring this guy here, and I'm gonna direct the routes. Yes. Okay, switch back to the bottom, and then Yes, so now we have enough space. In fact, good amount of space. Wow, but not here. Hmm, not here. Anyway, let's get here before we even think about this. Select U to select the entire length and then set it to zero point 0.3. Okay, so now that is 1.3. Let's see if we can squeeze some more space. All right. Okay, so now we have space here for our DTR signal to pass through. Let me turn this off for a moment and then get rid of this. Yep, I think we good. Okay, now looking at this, okay, can we route on the bottom? If we route it on the bottom, we can probably escape without any crossing anymore. Before we do that, let's drag this guy some a little bit away. Okay, so if we want to draw it on the bottom, then we will have to replace this, change this so that the DTR comes out. Okay, and I can still join this here, just join it here, or just join this here. My friend, this is okay. Then I can route my DTR, but if I route it on the top and I come up here, I'm gonna have issues. Okay, I'm gonna have issues. So right at this point, I'm going to switch to the bottom. It's too big. I'm going to set it on 0.3. And like I said, this signal, fortunately, we don't have to use it that much because we only need it when we are uploading code. That's all. When we are, so I can escape through here. This is escape from Sobibor. Okay, and it is there for. So let me take it away so that I don't. Uh, Probably just target here. Yeah, and it is too big. So this I need zero point 0.2. So again, you see, this has a potential of causing reflection. So what I'll do is I'll press U to select the entire length and change it to zero point 0.2 so that we don't have reflections on that line. We talked about that in the morning. So I'll press E and set it to zero point 0.2 instead so that it's uniform. Okay, we are making progress. We are making progress. We are making progress. We can deal with this 5 volts line just like that. Okay. What else? What else? Yes, this uh, we can actually ignore this signal. This duplicated A4 and A5. Okay, so let's vote. Should we keep it or should we eliminate it? I mean, it's going to add unnecessary complication to our routing, right? It's just going to be unnecessary. Now we have to find a way to route it. Meanwhile, I mean, who even uses these things? So let's vote. Should we route or should we ignore it? Yeah, should we route or should when we ignore it, that saves us two route because they are just a duplicated signal. It's just a duplicated signal. the SDA and SCL line. Okay, it's just duplicated. But looking at how we have managed our things so far. Okay, so I have let's ignore it. I actually strongly think let's ignore it. Okay. Yeah, any other?
Ignore it. Let's ignore it.
Let's ignore it. Thank you guys. Because now this was going to give
Let's
me.
ignore it.
Thank you, thank you, thank you. This was going to give an unnecessary headache. Okay, so if we want to ignore it, then let's go back to our schematic and take it from there. So schematic. It's when you are routing on the SMD version, it is easy to connect it actually. The SMD version, it's so easy to route. But then this one, okay, so if we are ignoring it, that is going to be this lines here. Delete, 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 and don't forget you have to put no connection on it. Okay, all right. I will still leave the pin at a count of 10 so that it will be compatible with Arduino. All right, so yes, that saves us that. We still have the reset to deal with, but I think the reset, right, we could probably pass it through here. Again, how to start learning signal integrity and concepts. Okay, so for signal integrity, I think maybe the best place you could start from would be Altium Academy. And PCB Africa also has nice videos from Mr. Daniel Beaker. And yeah, you can also check. So Atom Academy has videos with Rick Hartley, Lee Ritchie, Zach Peterson, yeah, Zachariah Peterson. Yeah, so you can check there. Okay. And for me, I subscribe to this Signal Integrity journal. So I receive some publications. Okay. Then, yeah, there are some books. If you, this man, I've forgotten. It's all about the space. Oh, Mr. Daniel Vickers' mentor. Oh, I think in the last session I'll bring out some of the recommendations. Okay, I'll bring out some of the recommendations. Yeah, but next year we will be bringing you a series of these things, both. So on the PCB Africa platform, we'll be doing the theory aspect. Then on the Let's Route platform, we'll be doing the live route. So whoever is being invited to Let's Route, the person will actually be explaining the concepts with practical. Like you'll be routing and explaining the concept. Okay. So yeah. I'll make a list and probably push it on the page for you. Okay, there are tons of stuff, but then there are also a lot of noise. If you don't take it, you end up learning unnecessary stuff, right? So yeah, just probably follow me on LinkedIn. Yeah, I have a lot of these people with me. Okay, thank you. Okay, so let's think about something quickly. Okay, this RST pin, if I route it here, I'll end up interfering with this analog pins, their ground plane. I don't want that. Okay, but technically the RST pin is not something we'll be using so much, right? So if I route it on the bottom along this guy here, the only worst thing that could happen is that, okay, let's assume this VCC signal actually induces voltage in this RSTP. By default, the RST is supposed to be high. It's even connected to, it's pulled up, right? So even if this guy sends anything to it, it's not going to harm it in any way. Is that okay? Fortunately, this is not a changing path. It's not a changing signal. It's a DC signal. So that influence is not also going to be any much. Is that okay? So I'm going to route the RSC on the bottom side. I'm going to disturb the plane for this guy just a little bit, right? And get out of it. And now make sure you don't route too close to the board edge, okay? So that in case their router malfunctions, still have a problem over here. Okay, so there is a way we can avoid this. Let's reduce it from 0.4 to 0.3. After it's not dealing with any heavy current. Okay, so let's do that. Okay, so we can now manage it through here. Now this hole is this green part that's actually the hole, right? This is the clearance for the hole. So for now, let's target along. I'm very afraid that the router may miss but of course it is on the surface. So even if it does, we can still fix it. We can still fix it. Okay, so that actually would help us deal with the RST. But we can actually also take an advantage of the fact that we have already placed this, move it a little bit away, okay, and then increase the space here so that we can, instead of jumping on the RST, we can just move it, okay, and again, clear, rearrange, do the same thing for this, and then we can conveniently route our RST signal. Now that we're done, we can bring this guy, this resistor, yes, so that and move this to a little bit away. Change to the top and change the signal. Okay, I think so far so good. So far so good. Let's just pray. Okay, we can actually squeeze the adjust the distance a bit. We good. Somewhere there. Now it is too close to that. Okay, let me zoom in and hold shift. I want to put it exactly in the middle. It looks about this right here, and we can do that. Yeah. So I think the clearance is okay. The clearance is okay. Now ARF. Another stubborn guy. But the ARF, the analog reference, technically, unless somebody wants to, unless you want to change your analog reference voltage, you don't use this. But then we don't also have to allow so much impedance. If I was the original router of the Arduino Uno, I wouldn't have sent this all the way here because the ARF is used to change the reference voltage for the analog signals. Okay, and routing this all the way here, that's so much inductance in the path. So okay, fine. If this capacitor is even buffering it, we still have losses on the path. If I was the original router, probably I would have used this one of these. I would have placed it on one of these things. Okay, instead of this being here doing nothing. But anyway, that is how they've already done it, and that's how we also have to do it. So I am looking at a okay, we can. No. If we go through here, we are going to discuss so many stuff. And so we can actually go through here. Oh, okay. What if, can I squeeze it under this? For instance, if I go to 0.3, okay, change it change to this line. Can I squeeze? I cannot squeeze. Oh, I'm gonna point two. And now I'm doing elimination by rough tactics. Okay, this is not gonna allow because I've already routed this, so let's delete this in the meantime. So I'm going to set the signal to point two after all, just the BCD can do point two. And if I'm able to go through this path, that's actually okay. In fact, if you look at that Arduino, but you realize that they also route through this piece, so I'm not committing any crime. Now, and this thing is not something that, but that is not a good idea to move it closer to. If I do this, I'll be moving it closer to a digital signal, right? And that will not be a good idea. So let me backtrack. Okay. So that means I can actually pass it through here, or I will have to probably route it along here. But if I go this way, that will be so much impedance. The reason I don't want to route it through this digital pins is because if I do that, if for instance, pin 4 is capable of PWM, if you look on the Arduino pin 4, okay, pin 4 is not capable of PWM, but when the voltage edge, okay, when the rising edge of the voltage is, when you are switching and the rising edge can actually cause disturbance on it. And since it's supposed to be the reference voltage for the analog, it's supposed to be very quiet, okay? So that's why I'm not going to route it through. So right now, I don't want to pass it through here to distort my anyways. Okay, so we have a ground here, right? We have a ground here. So we can actually make it tag along this ground up to this point and eject it. Okay, so let's go with that. So we put it on the bottom. We put it on the bottom. Over here we are not distorting anything. And yeah, so if we do an orthogonal crossing over here, then we will let it tag along this ground. Okay, tag along this ground. So we are not causing any disturbance, and I'm using 4 so that we don't have so much. So when I am ejecting, I go orthogonally. That means I don't cause much issues, and then we can peacefully move. I think I would like to set this on point 3. Point 4 is too thick for it. So edit and set to point 3. Okay, I think this is good. Let's correct something here. Okay. All right, so let's go and finish the trees. Let's complete it. Okay. Is this, no, there's not a ground. I don't want to cut through this. Okay, we only have 5 volts. I'll be needing to route TX and RX. Hey, I should have routed those guys already. All right, then let's bypass. Let's pass through here and go under. I really don't like this idea of the trace is too long. The trace is too long. The trace is too long for something that's supposed to be a reference voltage. Okay, but for now, let's see if we finish with everything and it looks like there's a better place to put it, then we'll do that. Okay, so this 5 volt, how do we deal with it? This 5 volt, we would actually route it underneath. Okay, so let me clear this guy. We'll come back to it. So this guy has a changeover. I'm going to create that change here, and then I always want to straighten my route. Okay. So once we have this, and what signal is that? The DTR. We only need the DTR when we are uploading code. So of course, if we tag this along, that's no problem. We tag this along. It looks like there is a block. Let's see, can we save it from here? I think so. And then let's get rid of this and that and that and that and that. Okay. All right. So correct the routes. Correct the routes. Okay. This 5 volts, so I want it to be much thicker. Can we actually move this? Seems no. Okay, we cannot. If we cannot, then we have to find an alternative. So an alternative would be to adjust this, okay, so that we can move this guy because I don't want to compromise on the thickness of the 5 volt pin. Okay, if you are loading a bootloader, if you are doing a bootloader, sometimes uh, you power your Arduino from this pin. Okay, so this trace should be thick enough to reduce the inductance because again it is too far away. So, all right, so now I can move this guy here. So like I said, routing is a matter of strategy and science. The two goes together. Strategy, you need to have strategy, and then you also apply the science. Okay, so now we can actually move this. Yes, yeah, we can move this here, and then we reroute it. Okay, go to the bottom and then fix this, and then get rid of that and that. Okay, so that now you can do this, and this is now free to move. Okay, we still have a block, but it's nothing we cannot fix. Let's see, can we squeeze some spaces over here? Yep. Can we squeeze some spaces? The answer is yes. And that. See, the reason I'm not very bothered about this side, it's not part of the daily activities, okay? Yes, it connects to the things here, but I mean, by the time the signal gets here, you don't have to worry about this place. Okay, so now if I route my 5V, I can come back to clean them. And this is 5 volt, that's RX. That's okay. And to that place. Okay, so now let's see if we can clean a little bit. Okay, and do the same for this. Yep, and now about that. Yep, okay. If I push this here, will it be nice? Hey, nope. Okay, all right. Yeah, so we've dealt with this. We are done with the ICSP. Now, a major thing, our RX pins. But again, it is not any big deal we can handle. And we also have this 3 volts and reset. So for whoa. There is a little bit of problem. Actually, is it a problem? This LEDs here, we haven't placed the LEDs yet, but that wouldn't be a problem. We still get a place to put them and it will still be here. We probably have to rearrange them a little bit. Okay, so right now the most pressing one would be this RxTX. Now RxTX is supposed to come here. Fortunately, unfortunately, we can't actually cross because it's like every place is used up. Every place is used up. RxTX. This is gonna be challenging. Every place is used up. Every place is used up. Every place is used up. But there's a signal we cannot ignore. Hmm. It's a signal that cannot be ignored. Okay, okay, okay. I'm going to do something. I'm going to do something. I'm actually going to route through this. Okay. Huh. I can't also do it back here. I can actually do it back there. Just that the lines will be very long. Okay, let's look at the frequency of UART communication. I think I know it's in the megahertz. Let's see if we extend the trace so long too much. It will not cause any problems. Okay, so Arduino, not Arduino, at mega 328 U at speed. Whoa, okay. From 1 megabit per second to that every year. Okay, okay. That's not much of a speed, but yes, it is. Mm, not much. All right. So then let's go with this. Let's go with this. Let us cross through like that. Okay. We will do it so that we are very close. Okay, we are very close. We will put them very close, and then not to disturb it so much because the thing is, no matter what, we needed this guys. Okay, and I don't want us to have so much inductance through this. So I'm going to route these guys to this point. We cross over this blue, we change and we come here. Because as it stands, there is no other place we could route this. No other place, no other place, no other place except that place. Okay, let's see. Can we manage it under this on the top? Yes, we can, but when we get up, we are gonna have issues. Gonna have issues. Gonna have issues unless we route it on the top layer and through exit through these holes here, get it here, route it on the bottom and take it there. That also works. That also works because now over here we don't have very sensitive signals. Okay, even those that we have, they are the aggressors. And besides, all the digital pins are co-planar, right? So I think that should work. Because if we want to take it through here, we are going to cut across so many. Okay, but if we manage to route it through this side, we just cut across a little, and I think that should be fine. So this is how what I'm going to do. I'm going to route them from here on the top, because you have space up there. You have space on the top. Yes, and I'm going to. Oh, unfortunately, this thickness cannot go through. And if we want to go straight, oh, actually we can go straight. We just have to sacrifice this 5 volt signal for now. So let's get done with this RFCX, because they are very important. Okay, so I'm gonna move them, and I'll go straight up through here. Okay, so that's these signals, I'll have to readjust them if I really want to do this. Okay, it looks like this will be our best shot. So let's see. You can move this guy somewhere here. Oops, we have changed impedance. So let me rather take it on this. How much time do we have? 3:30. Just 30 minutes. Okay. You can do a lot in 30 minutes. Okay. And then the next thing I'm going to do, go to the blue zone. Okay. And bring this, reroute this, so that now I can bring this guy closer, move it. I want to squeeze some space. So I'll bring, okay, now it's violating. All right, over there. So I can do that and that. Okay. Now I can bring this, okay, violating closer. See this bump here? I can actually eliminate it. I can actually eliminate that bump if I do this. Eliminate it, and then eliminate this one, so that this ground can actually tag along properly, and then squeeze, bring this guy here and do that for it, do that for it. Then finally we get to do this, we get to do this. Okay. I think there is still a problem. If we even get to this point, how do we get out? That is also another issue, because we have actually crossed so much. How do we get out? How do we get out when we get here? How do we get out when we get here? How do we? Okay, again, let's do some adjustments. Push all these ground guys to one place. So we are still applying strategy. Okay, that says us some. Okay, so I think, okay. So look, let's go and bring this signal. Okay, so TX, let's bring them closer to probably give us a better view of everything. Readjust. Let's get them closer. See how. Come on. So please, see, the last time I said the only interesting part of PCB or hardware design is when you are taking the money. Okay, every other thing is boring. Okay, so let's clean this up. All right, let's get the thing closer and tag this one to along. Now these guys are moving in opposite directions, so I mean, shouldn't worry so much about. Okay, so now let's assume, yes, we still want to route through this place, and so that's our that's what we've done so far, right? So now how do we get these guys to escape? That's what we are trying to, the problem we are trying to solve. Okay, now look at this. uh can I shift these blues maybe much closer? I shift these blues much closer, I could jump. There should be a means to jump out of here over there. So let's see. Let's close, let's close in on that. Okay. Move this somewhere here and reroute it. Okay. Reroute it. Check the top. Let's do this one for me here. Okay, so move this guy back again. Move this guy back again. But actually, you can move him more. This is actually a ground. Okay, it's actually a ground opener that we did. So you can actually do something to it. Maybe instead of terminating it here, you can move it to somewhere other than this place. Okay. For now, let's delete it right now. But you have critical issues to handle. I should have routed this guy first. Okay, then can I move here? Then maybe instead of here, I can change my direction at this point instead. Okay, let's see. We are still going to get that signal out. Okay, even if we have to probably reduce the width a little bit. Yeah, we will do that. Yeah, we will do that. Okay, we will clean this up later. But right now, what I'm trying to do is to gather all the blues so that we can jump over there. And this guy here, and move him closer and tag him here. That works. And this guy, we can't move him any further. So you see that now we've actually cleared this place, so we can route blue signals to the top correct. Ah, that's so fantastic. Okay, so let's clear this up. That means there is also a ground. I'm moving a little backwards. Okay, little bit backwards and also flatten this guy. Right. Then we get enough space to connect this guy. And we have more room here. More room to do what? First of all, break and then move out. Okay. I can see there is this ground here. I can actually move him a little bit away and fix the line. Yep. Now go back. And this A ref, we can give it a little more breathing room over here so that we can actually switch at this point. So I'll bring my RX line through here and then let's go and click the TX. So we again have to jump over here. Okay, so now let's tag along and move as if we all know one nothing. Okay, tag along. And ladies and gentlemen, that is it. We managed to get our signal out. So now let's clean up this place. Let's clean up this place. I think we even still have extra room, so we can manage doing clean. bring this out like that so that we can bring this out like that so that we can have enough room here for our to put back our ground over thingy. Okay, and let's go back to that's that. So now I've made my points. PCB design is our strategy. Okay, yeah, what's up? Okay, I think we're good, right? We good. Yeah, we good. We good. We good. Ah, yeah, we created a problem here, but this problem is much easier to solve. So let's see. We can actually open up this guy and route our signals along with it like this. Okay, so that our RX and TX can tag along. We need them to move as if they all know one another. Uh, I may have to do this. I may have to do this. Yeah. Even I think we've been doing something wrong because here we can only route it on point two. Okay, we can only route it on point two, and actually we need this pin when we are doing code upload. Okay, so I'm going to select the entire line up to this point. For the side that goes to the header pins, I'll leave it intact. So I'll select this part and make sure I don't have any reflections. So I'll put it on point two. Can it actually accept? It should be able to accept 0.25 or even zero point 0.3 should go. Let's see. Yes, zero point 0.3 is zero point 0.3 is okay. Zero point 0.3 is okay. All right. Then finally, this is the RX. So the RX to let's get that guy on point 0.3. Oops. So technically, it's only accept. So fine. Let's go 0.2. Okay. Then we will change layer. We change layer and get it connected over here. All right, so now I can edit and put everything on point 0.3. Okay, though there will be some clearance issue here, but we can ignore it. Yeah, who is there? Yeah, some clearance issue, so you can ignore it. Okay, so our RX and TX are out of the way. So the rest, yeah, let's find some. Okay, so let's get rid of this particular. So we need to put it on point two. Okay, yeah, we can actually connect that here. What else? Yes, this is the next major problem that we have. The next major. Now this 5 volts. Okay, we actually have a 5 volt signal here. So we have 5 volts coming in here from somewhere. There is a 5 volt line here. There is, okay, so here is it 5 volts. Okay, so look at how I'm going to solve this. This is a 5 volt line, right? So I'll target here. Now, since I can't move on top, Since I can't move it on top, I'm going to target just about this point, right? And then switch it so that I can do this. Okay. I think this also works. Let's correct it. All right. Huh. Cool. Okay, what else? So it's like down here we are done. Oh, now our 3.3 volts. What should we do to this guy? 3.3 volts. 3.3 volt. Actually, that should okay. But let's get rid of the RST first. I think we can still continue to route our RST through here, through the back. Yeah, let's just do it through the back here, and then where can we break off without any match? Okay, let me just get it into the main. No, 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 no. Okay, probably here. Wow, I have disturbed my ground plane too much. Think probably if I should get some more time on it, I can clean it up very well. But the last time I really enjoyed routing a board for a two layer board for Arduino, it was the I used the SMBIC and it was really cool, really really cool. Okay, so oh actually, hmm, let's see something. Instead of passing through that place, we could, I mean, having a pin here, having a branch here wouldn't hurt that much. So instead of adding all those inductance, we can just target along this side. And in fact, this guy, let's close it up a bit. Let's close it up a bit. Not under. Somewhere here is okay. Mm, okay. All right, so that we can close in for our RST. Hmm. Okay, so we can push a via at this point and then connect it. Yeah, okay. And then let's get rid of this U to select it. Oh, okay. I'll definitely clean up. Definitely clean up because if we are doing this, then technically we don't even have to go and come. This part wasn't touched, but then we still haven't placed our guys here. So for now, let's leave it. So over here, yes, we have to get rid of that and that, yes. So our reset is out of the way. Okay, our reset is out of the way. Reset is out of the way. Technically, we can do a little cleanup on the reset pin. Oh, oh no, 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 no. Can we? Okay. So look at this. If I pass the reset pin, it's not gonna move. It's not gonna move. It's not gonna move. Okay, then I'm gonna change this guy. Hmm. Let's do something like this. Push a little here, and rather have this here, so that my reset pin can actually move like this and then join over here. Then I can get a free space to route my 3.3 volts because it's much more important. Okay, so now 3.3 volts over VCC, that also doesn't sound like a good idea. That doesn't sound like a good idea at all. That wouldn't be good. So if I want to do my 3.3 volt, then the best way, oh no, now I can't cross over here again. All right, so let's undo everything we did last and instead move my 3.3 volts on the top. Okay, I can actually save some space by moving this guy here. Hmm. Yes, I can do that. I can save some space. Now let's put a 3.3 volts on one. Okay, let's see. Can I do some adjustment to this? Yes, can, but that is almost like how best I can move. So what I'm going to do is I'll quickly change layer and move this, but put some good spacing in between, and oh, I think we're going to have reflection issues here. So okay, I'm going to join it, then we change the net. Okay, so select everything. Now this looks like zero point 0.5, I think it's zero point 0.4. Mm, zero point 0.4. I think I'll make them zero point 0.5. Zero point 0.4 is too small. At least this is going to a cap, so no problem. So let's set this to 0.6. Set it to 0.6. And probably just a little bit of rerouting. Okay. Yeah. Okay, so let me make this guy nicer and straighten this. Okay, so we're done with the business of this place. How many minutes do we have? We have 7. Let's see what we can do with a 7. Okay, so I seem to have a broken ground. So let me fill it and see who. Oh, okay. So the ground here is broken, and remember I said I need ground to surround this pin, so I'm going to push VS here, one here, one there. That will do to bring. Oops, it still couldn't. Okay, then that's what I'm gonna do. I'm gonna route the ground manually and then terminate it here. Okay, so I know that this thing is surrounded by a ground. Let's see. Can actually adjust this a little bit. Okay, progress. So here you can see there is a break here because this is a hanging ground, and we can actually solve it by pushing some good VS through here. That should solve that ground. Okay, what signal is this? And okay, there is also a broken ground here. It is not this, it is actually this signal. So how do we solve this one? Yes, we can tag some VS on this. So 1, can always create and use the array creation. So here I think we can take 4. Okay, yeah, so that's for me, and that issue is resolved. We also have a broken ground, so this ground is also hanging. I think I'm just gonna go ahead and select these 3 guys, Control D to duplicate them, and bring them here. Okay, so that solves that ground. Okay, now our major, oh, we also have a broken ground here, so we can actually solve this. We need to push some ground bears here, and I think the problem is still persisting. These guys, I think they have to be separated. Yes. Okay, so this is much of a problem. It's much of a problem, much of a problem. Okay, but we can still solve it. We can still solve it. It is a problem, yes, but it's solvable. How do I resolve this? Oh, okay. So look at how I'm going to resolve it. Let's push this a little backward. Oh, did I cross anything? Okay, if you won't allow me, I'm gonna delete. Okay, then I'll move this backwards. Move this one to backward like that. Hmm. Okay, and then I can connect, right? Right now, whoa, I couldn't save much space. Okay, let's see. Go to the top layer. So look at what I'm going to do it. So I'm going to push a ground here. Actually, the reason that bottom is also broken. That side is also broken. This side is also broken. No, this side is actually not broken. So how about I move this a little bit here, and then route it, correct the route, but route my ground here. Okay, so this signal couldn't tag itself on the ground, so let me this via route a ground. Okay, route a ground, route a ground, and route a ground. So yes, yeah, that's also works. Okay, yeah, and that prevents this orphan ground I have here. Yeah. Okay, so now the last things we have left are these guys. So, ladies and gentlemen, the first. Wait, are we supposed to break at 4:30 or 4 o'clock? We started at 1:30.
I think 4:30.
It's supposed to be 4:30. Oh, okay. Then we can finish. We can finish. That's cool. Okay, let's solve this ground too. Let's solve this ground. You can see that there is an orphan ground here. So this one can be solved with a beer. In fact, yeah, it's okay. I solve that with a beer. Okay, so let me take this away now. Let's think about this, guys, for a little. How do we arrange this? Now, we need pin 13, LED 13. Yes, we need it. So I'm going to ungroup this and see. This guy here is LED 13's LED. pin 13's LED, right? We can successfully, no, yes, we can successfully put it here and not have any issues. Not have any issues. Is that right? I think so. LED 13, that can be here. Let me give it a briefing space because I'll be labeling. Then the RxTX guys, these RxTX indicators, uh, I can't put them here now because now they would interfere. However, if I still want to keep them here, it is possible. Okay, actually, it is possible because we can make some adjustments, bring this down, and I'm going to reroute these guys a little bit down. Okay, that can save us some space, I think. So let's also move this a bit. That should be able to save us some space. So let's give that a try. Okay, so instead of going through here, I'm going to drop this guy and tag him here. We will correct it later. And here we have co-planar guys, so we can let them tag along smoothly. So that will be our last headache, and we are done. So when we come for the last session, we would place an order on JLC PCB. Uh, yes, I'll show you how to do that for the sake of those who haven't done that before. But I'll cancel the order. But later, I'm going to talk with, I'll have a chat and then we will see. I want us to have another session where we actually mount components on this board. Okay, so if you are interested, then you could actually, I will leave the boards at various places. Now, if you're in Ghana, I'll be leaving it with our sponsors who have shops. Okay, so you can go to them and buy a copy from them. If you are in Kenya, I'll leave it with Code Innovators. You can go there and buy a copy for yourself. So we will after doing that, we will schedule a day. Then I'll show you how to do the lives. I'll do soldering live for you to also do along. Do you think what we are doing is actually going to save us? Okay, let's see. So we would actually assemble this. Then after doing that, we will have another program where we build a project with it, and I'll show you how to program hardware, firmware. Okay, create devices. So I know most of you have probably done these things before. So I'm looking at the newcomers, and I mean, if you're a guru already, yeah, you could still try it out. Okay, so if you are not in Ghana and you would want to be a supplier for the board, please after this just DM me. Okay, we will ship it to your address, then add the components so that people can pick it up. Okay, but that means your country should have a lot of people on the platform. Okay, if you are just the only person, then you would have to maybe find another means of getting it. All right. Yes, I think this should say we will definitely have to clean this up again. And I mean, whoa, I doubt this is going to do us any good. Hmm. Anyways, we've already done it, so let's finish it. At least it will save us a little bit of space that we can use to then afterwards we can adjust things. Hmm. No, 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 no. I couldn't get enough space as I wanted. Couldn't get enough space. Enough. Okay. At least we have some space. And remember, everything is about strategy. So we just have to make it work. Okay, okay. If it comes too much, okay, okay. Look at something. Actually, two of these are supposed to be indicators that we are programming something, right? Uh, I can probably separate them a little bit from the IC, the LED3, and bring the LED3 somewhere here. Then I get to adjust this guy on its own, or then move it up here. And if I move it up, yes, I think if I move them this up, that could work. If I move them this up, that could work. Or, or another way I can actually do that is to bring their resistors down like that. Bring their that actually solves the problem. Bring their resistors down, and that gives us a lot of space. Oh, fantastic. Okay. All right. So by bringing their resistors down, our problem is solved. Okay, but I think we still have to do some rearrangement. Okay, so if we bring their resistors down, then now let's continue with what we're doing here. Move, move, uh, move, and then move. How come this has been tagged as a 5 volt line? Whoa, how did that happen? That's been tagged. I think something went to sleep on it. Hey, that's dangerous. It has been tagged. Look at it. It has been tagged as a 5 volt line. You see? No, 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 not 5 volts, please. You are supposed to be. I'm not supposed to be 5 volts. Okay, fine. Let me get rid of it and do it again. If I didn't see this, that would have been catastrophic. If I had not seen it, it would have been so bad for us. Okay. Yeah, so this you are supposed to be a ground, not a 5 volt line. Okay. So please, when you are doing these routings, be careful. Okay. Probably in the course of moving things here and there, we tagged it onto a 5 volt line. Okay. All right. I think yes, this actually doing this solves our problem. Mm, let me correct this. Okay. So doing this solves our problem. Please, you guys should try to route this thing for yourself, okay? At least even if you can't build the schematic yourself, take the image, try, and I'm going to share. I'll share the finished work on GitHub, and I'll also destroy one, put one version that is not routed. Okay, so what we will do is if you route your board, you take an image of it and then share it on the on our WhatsApp page so that we could look at it. Okay. All right. So the last signal, and we good. Mm, okay. So, yep. Now let's clean this side. Let's clean it up. Think let's move. Hmm. Let's just clean up. Yeah. Okay. 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 Then the last one. Okay. Yep, I think we're good. Now take note, this thing seems closer, but they have grounds in between them. Okay, so they are coplanar planes. All right, now let's finish up with this guys here. 5 volt, 5 volt. I think the orientation is okay with exception of this one. So let's rotate it. Yes, and now we're good. Yeah. Now I'm going to make sure they are aligned. So I'll use this as an anchor, align to the center. Do the same to this. Use this as an anchor, align to, in fact, before I do that, let me align their parents. And let's, we now have some space to spare over here. So let's move. Yeah, then I'm gonna align this their LEDs. Okay, so I'll align them and then also ensure that they are equally spaced by selecting vertically distribute. Okay, then I would set this as an anchor and then use this to align to the middle. Do the same for that. Use this as an anchor, align to the middle. Align middle, align, oh yeah, yeah, and then this already aligned. Okay, so you see now the routing becomes simpler from here to there, there to there, that to this, and our pin 13 is here. We have a ground. Let's get rid of it. Now we have 5 volts here. Not a good idea to do this, so I'm gonna change the net to zero point 0.4. Yeah, now okay, we already have the 5 volt signal here, so tag along and pick the signal. So we are left with, whoa, we still have something. Okay, so this is power. This is for power. We can't tag it along. This is for power. Now the Arduino, it has its power somewhere here. Okay, the original Arduino, the on is actually somewhere here. So probably we could also do the same thing. Okay, so let's get some space here and do the same thing. So this is what I'm gonna do. This is what I'm gonna do. In order to close them, since we want to have the coplanar something, I'm going to do this and then tag. But so let me tag it to the middle. Hmm, somewhere here. Okay, I want to speed up some spaces here, and then I would do this, push them along. Okay, not a good thing. Come on. So I think we can clean this. And it says this is off, so let's get rid of it. Okay, so let's delete. Yeah, we are bringing them closer, but still co-planar, and then we can we can squeeze the space. Unfortunately, we have 5 volts at that point already. We have 5 volts at that point already, so we won't be extending to any place for power. Okay, I'm going to create another. Probably after doing it, you can clean it up a bit. For now, we want a strategy to work. Okay, so and please, when you are routing, at least add some aesthetic quality to it. Okay, let your board look nicer. Okay, yeah. So you should also have that in mind that your board has to look nicer, so that the okay. Then I just want to squeeze enough space. Once I have the space I want, yeah, I think as we bring one, two, and three over here, that should give us the space we want to push. Okay, clean it up. Yep, and finally, last but one. Okay, good. So you see, when we clear this up, then we have a lot of space down there for ourselves. Fortunately, all these guys are co-planar, so we don't have any issues on that. Uh, Let me bring these guys a little bit here. Yeah. Okay, from here to there to there. Then move it, move it. Okay. So you see that I'm trying to make this VS align, right? It's just to add beauty to the board, okay? Just to add beauty to the board. So when they align, it rather looks nice. Okay, let's zoom in and try and straighten this. Yeah. Okay, so now finally we get to move this, and we have so much space for ourselves. Okay, so much space, so that we can now bring this guy and position it like the Arduino. All right, Hassan, yes, please ask your question.
Okay, so thank you very much for this session. I really appreciate it and it's really very
I can't
beneficial.
really hear you.
Okay, I said I really appreciate your effort so far. So I want
Thank
to
you.
ask you a question
Okay.
concerning the this signal lines you just brought closer to each other together, the
Yeah.
phases. So like I've once came across a particular place where they normally talk about something called, is it not coupling, or
Something called what?
like whereby the signal, probably signal from one phase will affect the signal of another phase.
Yes, crosstalk. Crosstalk.
Crosstalk, exactly. So crosstalk. So won't that occur in this kind of
Okay.
scenario?
So you realize that if you look here, can you mute your mic? Thank you. You see, this is a digital signal. In between, we have a ground signal, another digital signal, ground signal, digital ground. Okay, so that is to handle that crosstalk issue. Okay, so what we've done is that we've routed this as a coplanar waveguard. Okay, so that actually handles crosstalk. So all these signals are sandwiched between grounds. Are you okay?
Yes, sir. Yes, sir.
All right. All
Thank
right.
you, sir.
So that's why I'm doing that because I wanted to close up the spaces between them. Okay,
Thank you very
so
much.
thank you too. Right over here, and I think this. Oh, I thought that was going to be our last. All right, I'm not going to push any via. I'll just take the power parallel over there. So we are done with that. So who would route this last three? Tell me where I should pass them, and then we go. Who route the resets? The resets. Who route it? Yes. Any takers? The reset. Who want to give it a shot? Where you think we can? Actually, the reset is straightforward. From here to here. All right, Hassan. Yes, give it a shot. So I've already done the reset. So you could probably try this 5 volts here. How do you think we should route the 5 volts? Yeah. Hassan, I thought you raised your hand, right?
Oh, okay, okay. Oh, sorry.
Yeah.
So I forgot I didn't almost my mic. Like, okay. So for that one, 5 volts, you just need to like extend a top copper trace forward a bit. Then with a
We should
via
what?
that will link it, you should draw a top or what's it called a trace from the top copper.
Mm-hmm.
Then extend it out a bit. Then you are going to like place a via, and that via we then a button. Then that will link us to the button layer. Then from there,
Actually,
you then
so okay, maybe you weren't here yesterday. Mute your mic. Thank you. So the board stack-up that we are using, okay, we are using 2 layers, and all the layers have ground. Okay, we didn't pour power on it. Okay, so all the layers have ground. So it's not like the top bottom is 5 volt and no, they are all ground. And I did that specifically because I mean, this is just a 2 layer, but I don't want, if I pour, let's say 5 volt on the top, right? That means all these signals will be sandwiched in a 5 volts, 5 volt line. I don't want that. I wanted to have coplanar waveguards. In fact, specifically microstrip coplanar waveguard. Okay, so I have a ground plane at the bottom, and every signal on top is routed through a ground. Is that okay? So as much as it can, that gives you better stability than having power on the top. Besides, we use the 5 volt as specific parts. We are not using 5 volt signal throughout the whole board. Okay, it's not dense, so it doesn't make sense to actually pour 5 volt on the top. Okay, I don't know if you understand that. But you see, looking at this, we could just route this. Okay, I'll connect it here because this is already connected. Is that okay? I don't want to tamper with the ground plane of this place. So this 5 volts, we could just change the net. This net will only accept 2. And fortunately, this is just a reset. It doesn't require so much current. So yes, we can still proceed with the point 2. I think let's try 0.25 and see if it will allow us. Okay, it won't. So 0.2, even 0.2 is a problem. How come? Oh, okay. It's because the previous signal is not a 0.2. The previous signal. So let's do the 2 right now. Yes, and that works. Oh, actually, we don't even have to tamper with that. We already have no, but if we use this, look at it. If we could use this, but if we use this, we will cross these signals and we will have to jump. So Yeah, I'm going to use this, guys. I'm going to use this point 2 so that I don't have to do any crossing. So take note, I keep saying board routing involves strategy and science. Okay, so your strategy should be informed by the science. Okay, so we can do this. Okay, and nothing is actually disturbed. And then now these guys, we can route them here. Okay, but if we had used this for the 5 volt, then we would have crossed over these guys. But by doing this, we don't have to cross anything. And you see, they are parallel, so I can route them straight up. Same thing applies to this. And these signals are also just for indicating that there is communication. There's a UART, the UART thing is busy. Okay. Yes, that is all it is used for. Okay, and then yeah. So let's just close it up a bit. Is somebody trying to ask a question? Okay. Yeah, Hassan, please go ahead. Right, let me clean this up a bit.
Okay.
Yeah, Hassan, I'm listening.
Okay. So sorry for
No,
uh,
no, 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 no,
bringing
no.
it back. Okay.
I actually wished all of you were talking so much.
Okay. So the
Yeah.
my question is this: still going back to the part you said you apply the microstrip or kuplana guide.
Mm-hmm.
So there's this stuff that I've been finding it difficult to like really understand it, which is the issue of return parts.
Return path. Okay. Okay.
Yes. So
Okay.
in that aspect, where you place ground between those signals, and I've happened to watch one of, is it Rick Atlee or
Yeah.
YouTube stuff. So I was able to like grab some little things from there, but I could not really understand. So
Okay.
so I want to ask now that in those signals, like their return paths, where is it located? Is it is it located in the probably the ground plane or below
Exactly.
the
So
ground? Okay.
when we talk of the return path for high transmission lines, okay, it is nothing but the ground plane that is supposed to be under the path, under the trace. Okay, that is why I said initially that I'm going to try as much as possible not to tamper with the ground plane because I try to treat every signal as a transmission path. Okay, that means that I have to have a solid ground plane and direct because for high speed signals, the how do I put it? The return path is always right under the signal trace. Okay, so the return path is just a path for current to return, and that is usually a ground plane. Is that okay? So for instance, if I take this the differential signals, okay, you can see that underneath I don't have any route, right? So the solid ground plane over there will form its return path. And because it is a high speed signal, the signal will actually be contained along the trace. Okay, now take note, energy moves in the spaces, not in the conductor itself. Is that okay? So the return path is like that space between the ground plane and the trace itself. Is it okay? So we are talking about the return part of the energy. So it's the space between the ground plane and the 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 ground plane and the trace. Is that okay? So if you put anything across, then it's going to interfere. That's what how we have this kind of crosstalk stuff happening. Okay, because some signal moves in the path of another signal, and the path we are talking about here is actually the space between the trace and its ground plane. Is that okay? So that's what we usually call the return path. So having the the trace directly above a ground plane creates a transmission line and the space in there, so the energy travels back and forth through that same space along the trace. Is it okay?
Okay, thank you, sir. Yeah.
Yeah. All right. Is this okay? Okay. Okay. Right. You wanted to ask a question, sir. Okay. So does it look like we are done? No, we have something here. Yeah, we did cause a trouble here. And what error? You see, look at this. There is an error here. Who can tell us what the error is? Looking at this, there is an error here. Yeah, Hassan.
Okay. The width of the trace
Mm-hmm. So
is
what
not
is it going to cause?
okay. It will cause like probably a kind of resistance, like a reduction in the current required by that IC.
Oh, okay. So the technical thing is it's going to there will be a change in impedance. Okay, there will be a change in impedance. So we will have some reflections, but unfortunately, this is a DC kind of thing, so that wouldn't be much of a problem. But if it was some high frequency signal, then that reflection could be a problem. Okay, so we will still want to fix it anyway. So you make it a habit of doing the right thing. So I'll press on E and set it to zero point 0.2. Okay, so that yeah, I think we are done. Yep, we are done. We are done. We are done. How many minutes? Oh, and it's 4:30 exactly. So ladies and gentlemen, thank you for session 2. Please, if you have any questions, oh yeah, there is a broken ground here. If you have any questions, I'll be glad to answer. Yeah. Yes, so the last session, we are going to use the first 1 hour 30 minutes to do the silk and the designs that we want. Then we will have we'll use the last 1 hour for the get together where we talk about, so we share ideas and stuff. Okay, so that's what the last session is used for. All right, Jan, please go ahead.
Bruce, where can I get some of the board?
So are you are you are in Ghana, right?
I'm in Ghana.
Okay, so which part?
Yes, please.
Which part of Ghana? Which part are you? Which town or city?
Eastern region, Ngoko.
Mpoko. Okay.
Ngoko.
All right.
Yeah.
Can do we have other people joining from Mpoko? Maybe we'll do that survey. Look at where people are coming from. Okay.
Yes.
Then
Yeah.
if we happen to have a lot of people from
There we have about yeah.
You have about how many people?
About 15 or so.
Oh, okay, then good. So I am actually from Nkoko anyway. That's my town.
Okay.
My daddy's house is at Asuja.
Okay,
Yeah,
nice.
total Asuja, yes. So that's where I also come from. I attended. I do you know IBT?
IBT, yeah.
Yes. So that's where I completed 2003, and I went to St. Peter's.
Yeah, I know IBT.
Yeah, and I went to St. Peter's. So
Yeah.
I'm an Nkoko guy. So I will probably leave
Okay,
some.
okay.
I have a place I will leave some for those in Nkoko who want to follow through. Okay, so no worries.
Okay.
Yeah,
Okay, thank you very much.
you're welcome. Okay, so yeah, please any other question? Any other question? Any other question? I think we did good, right? Yeah. So this guy, I promised to straighten them because actually it doesn't make sense. There is nothing tying us to making them look like that. Yeah. Any other question? I think this is good so far. There is a broken ground here. So if you see that there is a broken ground, one way you can solve it is to fill it and check it out. Okay. So it seems the broken ground is here. So it's trying to get itself connected to this point. Wow, it's actually quite a problem. Actually, quite a problem. There is a problem. Okay, but of course, we are engineers. We solve problems. Now, please, when you are routing, make sure you don't get too closer to any drilling point, any potential drilling point. Okay, but sometimes if you don't go to a fabricator who has sophisticated tools, they can end up messing their drill points and drilling into your traces. Okay, and unfortunately, when the board is there, you may not see it. You may not see it, and you'll be trying to get it to work, and you may cry. Okay. Yeah, let me see. Yes. Still we have something to solve. Okay, so this reset. Unfortunately, I can't do anything about it. But that is not to say this problem cannot be solved. The problem can be solved. You just need a strategy. You just need a strategy. So the problem is here. See, this side of the board is not attached to the ground is broken from beneath, and that is the reason we have this issue. So let me see. Can I squeeze a little? All right, and I think that solves it, and it's stronger enough so we can allow it. Okay, so when you are done with the board like this, you have to actually verify that every connection is intact. Okay, so the way you do that is by running the design rule checker. There is another version of it here. Now, probably this thing is going to give us tons of them, yes. But the first one you need to check is unconnected. Okay, you see that unconnected is 0. But this guys here, track has unconnected, and this one they will come in a lot because as you are touching and dropping, you create loose ends. So the way you fix that is go to tools and repair board. Okay, there is no repairs to be done. Remove unused parts. This one to always run it. Clean up tracks and vias. Yes. So see all these collinear, they are the ones showing that error or unconnected and unconnected. So we say merge all, and now if we run the DRC again, whoa, they are still there. Okay, but we are not seeing the unconnected again. Okay, so these are all clearance violations. We will deal with them. Okay, so you see that we don't see the unconnected ends again. But the most important thing, schematic parity. Schematic parity means that nothing is in here, like there is no mismatch between your schematic and your PCB. Okay, that's the schematic parity. And another important thing, unconnected. So make sure this is 0. Okay, so for this particular guys, we will solve them. Okay, silk cleft and all that. We will solve them later. Then for this clearance violations, usually we can solve them by one click. See, if you look here, so the default, if we change this default to 0.2, that should deal with our clearance violation. In fact, even VCC to 4 instead of 5, that should handle it. Okay, so let's run again. Yes, okay, so now you can see that the clearance violation guys have reduced. So now everything is what courtyard, which we will solve in the next session. Now, if we also check this, yes, so that silk screen clipping, that one too, we are going to solve it in the next section. Now, always remember to delete those. All right, so let's take a look at our board in a 3D viewer. So that's pretty clean. Okay, that's pretty clean. And you can see that we actually didn't disturb our bottom that much. Okay, didn't disturb our bottom. So we have solid plane, almost good solid plane. And this is actually good for such a two-layer board like this. Okay, you realize that we really used the top part. We really used it. Okay, although we were even still constrained by space and all that. Now, take note, these guys are sandwiched between. In fact, one thing I can actually do, one thing I can do here, I can go ahead, select this, and change them from 4 to 3. That will also add more spacing between them. Okay, so yes, let me quickly do that. Select and point 3. In fact, I think I can. Okay, point 3. Come on. So if I put point 3 between them, that now gives us more spacing between them. Select all, edit, point 3. I think I changed the wrong one. Oops. I changed the wrong one. Okay, select all, edit, and point 3. Select all, edit, point 3. Select all. Please, if you have any questions, we have technically ended this session, but I want to do this thing before the next session starts. So, like I said, the next session, we are going to design the silk screen, and then we will also and do place an order on JLC PCB, so that those who haven't done that before, you can see. But we will be printing the board. Okay, if you're in Kumasi, you will get some at Texkins, Siratech, and Novitel. Novitel is in Accra. Siratech and Teskin are both in Kumasi. Okay, so when we deploy the components, we will let you know, so that those who want to follow that tutorial, you can grab your components. Okay, and let me say that the price will be a little bit higher than what you may get for an actual Arduino. Okay, it's just to help support us. Okay, you can even decide to buy it at a much higher cost. We will be so happy. Okay, but we are going to have a lot of interesting programs next year. I think in January I'll bring Zach Peterson. Zach Peterson would have a program with us, and then yeah, we have that kind of fun. So please, if you go to our YouTube page, subscribe and turn on notification. Okay, because we need to be able to get cash from everywhere to push this agenda. Okay, so I think we're good. Yeah. Okay, so these vases look close, but they are co-planar. Okay. All right. So thank you very much. See you in the last session, where we bring everything to an end. All right. See you at 6.